Last time, did we go through the test format? Did we do that? No?
You said you put it up, we never discussed.
Okay. Well, let's just take a minute to talk through it here right quick since we have a minute. This has been up, but, we'll talk about it. So you got two questions where I'm going to ask you to use the calculator to find the value for one of these inverse trig functions. This is literally like, can you type it in the calculator with the right mode on and write down the number afterwards? Should be some softball there. 4 questions where I ask you to use the unit circle to find the exact value of an inverse. That's like the first page of the review. Everybody okay with that? 2 questions where I ask you to use the unit circle to find the exact value of nested inverse trig and trig functions. So that's like these guys on page 2 of the review. That question 3 on page 2. Two questions where I ask you to use the calculator to find the value of an inverse over a specific interval. So that's like worksheet 3 for us, I think. Is that right? No, worksheet 2. Worksheet 2. I got my numbers wrong. 1 question where I ask you to solve the right triangles. That means like find all the side lengths and angle measures. It's basically just like a non-words version of a story problem, right? The story problems, we all just build the right triangles and then find a part of it. Here we're asking to find all the parts of it, but you took away the words part. You know what I mean, guys? So it's kind of like the story problems, just minus words. And then we have 2 story problem questions. That's the test format. We okay? Clear idea of what I'm talking about here, I hope.
Story problems like the buildings and cliffs.
Yeah, those guys. Like on worksheet 3, you had a couple on the problem set. You had a couple in the review. The big thing there is making sure you understand, like, when you're drawing your picture, the angle of elevation, angle of depression, where those numbers go, so your triangle's correct. But they all boil down to just like Sohcahtoaing on a right triangle. Jay.
Did you say the first 2 were on again?
So the first 2 is just like literally type it in your calculator and write down the number. You just have to make sure you're in the mode, the correct mode based on the directions, whether you should be in degrees or angle or radians. But it's just like type in your calculator, write down the number. Just to make sure that you can like use your calculator at the most basic level. Just in case. It's basically like these ones on question 2 from the review, where it just all you had to really do was type those guys into your calculator and write down the number afterwards. If it gave you a number, some of them are undefined because they're nonsense. But is that cool? Okay. Anybody else with chapter 4 questions on stuff you want to talk about before we get rolling? Joe?
Can we do for the problems on solving the right triangle, non-word story problems?
Yeah, sure. Sure, no problem.
Oh, Jack's here.
Oh, there he is.
Oh, with a pass.
Yeah.
With
So it's not tardy from Garcia.
whoa, is that because she was giving you tardies?
Yeah.
Just so you know, he has there are 14 tardies, guys. We were just discussing how you don't have like 100 tardies.
14. One more
So-
for Saturday. Actually, she forgot to write the date, so I had to go find her, and then
Yeah.
she gave me the pass.
Totally fine. I'll fix that for you so you don't get a 15th here.
Yeah. We'll be targeting to do that.
So just so you know, the people that are like, he's tardy this class every day. How's he not got like a million tardies? He does have a million tardies.
Yeah.
So
It's not just.
it's not just this class, I'm sure. You seem like a chronic tardy person. And I'm just giving you a hard time. But it's okay, because you're good for it. Because you're tardy all the time, and you know it. You're a senior. It's like, yeah, I know. I'm not doing a good job showing up on time. But anyways, yeah. Doesn't mean you're like a doo-doo face or anything. All right. So let's say, I don't know. Do that. Okay, so solving a right triangle example. Here's one. So the pieces that we're going to need the side length for CB. We're going to need angle BCA and then angle BAC. Everybody's cool with that? Those are the three things that we're going to need to find for this problem. And we know how to read an angle when it's written with three letters like that, right? The middle letter is the vertex. So like BAC is talking about angle A. Cool? Again, we should know how to do that, but geometry is a long time ago, so let's just remind everybody, right? Don't hurt. All right. So the tool here that we're going to be using is, I would say Sohcahtoa, right? Since we're dealing with a right triangle, we're going to be using the right triangle definitions. So if we're talking about angle A, relative to angle A, we know the adjacent and the hypotenuse. So we should use sine, cosine, or tangent. Cosine. So I'll say cosine of A is equal to adjacent over hypotenuse. So angle A then is going to be cosine inverse of 10 over 15. I'll go to my calculator. In a problem like this, we're probably going to ask for degrees in our answer. So I'm going to change my mode to degree mode. It would tell you in the question to write them as degrees. But the fact that you have that right triangle square in there should be a good hint that, you know, and the fact we have a physical triangle. When was the last time you had a triangle and I gave you an angle measure in radians? Right? We don't really do that. Anyways, I get 48.19 degrees. Cool so far? Okay. Now what do you want to solve for? Angle C or side CB?
Well, besides CB, just
Yeah. The thing you have to be careful there, though, is when we have a squared plus b squared equals c squared, what does c have to be? Hypotenuse. So we have to write it this way, right? Where the 15 squared is by itself. And then 15 squared is 225. So if I subtract 100 from both sides and then square root both sides, I get the square root of 125. You could write that as a decimal. Probably would ask you to round your answer to 2 decimal points in this problem, so let's do that right quick. First, I'm going to double check that 15 squared is 225. Okay, good. So 11.18. Then how do you want to find BC, or angle C? Excuse me. Sure. Yeah, or even easier, you can just do like 90 minus, right? Because the acute angles of a right triangle have to be complementary, but you could add up 90 and then subtract it from one. It's doing the same, you know, 6 and 1/2 dozen of the other. That's the easiest way to do that. So 4181. We cool there? The other way you could ask this question would be if I give you like an angle measure and a side length instead of giving you two side lengths. Still looking for three things, right? Still using the same set of tools. But the tools from our toolbox we're going to use will be a little different, right? One of these three is pretty easy to get right away. What's pretty easy to get right away? BCA, right? It just got to be 90 minus 37. Yeah, this is your question though, Holmes.
Oh, you have to try and answer. Oh, never mind. You're right. I'll stay here.
Like, you can go, but it's just kind of a weird request. Cool so far? Okay. Now let's say we want to find CB next. So relative to the angle we know, this is adjacent, and this side is opposite. So we should be using Yup. So I'd say tan 37 equals opposite over adjacent. To solve for CB, I'll multiply both sides by 10. And then I'm just going to type that into my calculator. So I get 7.54. Everybody okay there? Notice here I used regular tangent, not tangent inverse, right? Because I was looking for a side length as opposed to an angle measure. And then how can we find CA then? I could use the Pythagorean Theorem at this point, right? So 754 squared plus 10 squared is equal to CA squared. Again, making sure the hypotenuse is the C. So I'm just going to be taking the square root of that 754 squared plus 10 squared. So I get about 1252. So those are kind of like the two different iterations of this, whether you get two side lengths or you get an angle and a side length. I can't give you two angles and have you do anything with it though, right? Because what can you do? Like there's all, like they're all proportional at that point. Like there's not one side length that the triangle could be. Cool, Joe?
Yeah.
Okay. You can go, by the way. Like, we're done with your question now. Yeah, no problem. I'm just hassling you a little bit.
I thought you were done with it because you went to a different one.
Oh, yeah, there's kind of two different versions. Yeah.
Oh, that's well good. Thank you.
Yep. Jay?
Just do more like a story problem.
Yeah, do you have a specific story problem you want to talk about so I don't have to like try to make one up on the top of my dome? Because
On the review, I guess question 6.
okay, let's take a look at that. All right. Just FYI, I would not ask you something that's this involved on the test. We can certainly do it, and I'll talk about it.
Or will it like show you like
The one above it is perfectly reasonable.
that can you do that?
Oh, sure. That's fine. Whatever you want. I figure just as long as we're doing stuff, I don't want to waste
Yeah.
like and freak you out doing like the hardest possible story problem and then not have it show up. You know what I mean?
Yeah.
What's up, Aaron?
Is this problem 6 gonna be like harder than anything we're gonna see on the test? So,
Yeah, when put
and then question 7 is we're gonna see one like that then.
No, that's question 7 is perfectly reasonable.
Okay, so I should just
You can skip 6 in your preparations. That one involves like the algebra gets a little hairy in there. You end up having to solve a system of equations, and it can be kind of a lot. Not unrealistic for us to be able to do it, but I think it's more than what I would expect from this course to do in like a times test setting.
Like I shouldn't expect it to have like the model already there. Like we might have one where
You could certainly have one where you have to draw your own picture. Yeah. And in fact, I'll just pretend like I don't have the picture here and we'll draw it again. Okay. So it says a sextant is placed at ground level on a tripod 3 feet off the ground. So ground level. The sextant measures the angle of elevation to the top of a building to be 32 degrees. So this is our angle of elevation goes from eye level up. So that's the 32-degree angle. And we know that buildings we're going to assume are going to be perpendicular to the ground. Unless we're talking about the Leaning Tower of Pisa, but that's beyond the scope of something I'd expect you to be able to deal with it in this class. The sextant is 45 feet away from the base of the building. So that's 45. What is the height of the building? So here's the trick here. I have the right triangle here. I'm going to call that side H1. But this side, that little piece is also 3 feet. So my overall height is going to be H1 plus that 3. Cool with that? Jack?
wait, you 3 feet.
So this piece is 3 feet, right? So this is 3 feet. So this is 3 feet. So this overall, if from here to here, I'll pick a different color, is my side H. The overall height of the building is H plus 3, right? Cool. So since this piece is 45, that piece is also 45, right? So what I really am looking for is I have this right triangle, 32 degrees, this is 45, and that's the piece that I'm looking for, right? Looks a lot like that solving the right triangle problem we just got done with. So I'm going to be using Sohcahtoa. Which one do I want to use, sine, cosine, or tangent? So relative to the angle I know, I have opposite, adjacent, or hypotenuse. Adjacent. And this one, opposite or hypotenuse? Opposite. The hypotenuse is the longest side, right? So if I have adjacent and opposite, which one do I want to use? Tangent. So opposite over over adjacent. To solve for h, I'll multiply both sides by 45. So 45 times tan 32. And then remember, we still have that plus 3 to add on. So my final answer would be like 3112. Cool? Yes. So just, you know, something like that. Or you just end up with one right triangle and not two. That's the issue with 6, is that there's 2 right triangles in there and you don't know all the information for either one of them, so it just gets kind of messy. Ariana? Yeah. Yeah. Say hi to Joe. Tell him to stop pooping in the sink. It has been a while. I'm just joking. I know Joe's not the one pooping in the sink.
No. Can't be too sure.
Okay. Fair enough. I won't be too sure. I don't think it's probably him, though. Okay. We'll do that. All right. It says you're standing 50 feet from a flagpole, and you know the flagpole is exactly 48 feet tall. What is the angle formed at the spot you are standing between the ground and the top of the flagpole? So we're looking for that angle there, right? Okay, so relative to this angle, the 50 is opposite, adjacent, or hypotenuse. Good. And the 48 is?
Dude, I know what Jack told me.
That's opposite. So which one do I want? Tangent. So we'd say that tan 48 is opposite over adjacent. So tan theta equals 48 over 50. So then theta is going to be the tan inverse of 48 over 50. And then it's just calculator time. So the only difference here is that because we're looking for an angle, I know I have to use the inverse. So I get 4383 degrees. Is that okay? Anybody else before we get along, little doggies? All right, yeehaw, rawhide, let's roll out.